This conference will
Yeah,
now be recorded.
yeah, I'm doing
Krishna,
good. Will. So,
okay,
can you please introduce me about yourself?
okay. Yeah, I am Vel Murugan. I am having total IT experience of 15 plus years. I am working in Tech Mahindra for the last 15 years, and I am working in mainframe technology. So I have worked in both enhancement and production support in mainframe. Currently working for supply chain management and production scheduling domain. So out of that 15 years, I was in on-site for 6 years, and the remaining 9 years I am working in Chennai offshore center.
Okay, cool. Thank you for the introduction. Can you please tell me what is your roles and responsibilities in the last project? And did you get chance to work with AWS technologies during any time of your tenure?
Yes, Krishna. I was working as a SME in supply chain management and production ordering domain. And for the last 2 years, I am working in AWS Redshift.
Okay, cool. Can you
So,
please tell me what is your roles? I mean, what is your regular activities that you do in AWS project?
okay. So, coming to the regular day-to-day activity, so it's like have worked in migration earlier. We migrated from our mainframe database to AWS Redshift system. During that time, we created Redshift tables corresponding to the mainframe tables we had, and we loaded the we unloaded the data from mainframe system and moved that to S3. From S3, we loaded it to AWS Redshift tables. Uh, After doing the testing in dev region, we migrated those tables with data to the production region. That was the one we did during the migration. After that, during the regular support, we get ad hoc request for unloading tables and giving them the data in a notepad file or an Excel file. We unload and give it to them, to the other application teams, like or to other vendors who require those data, and we monitor the workload management queues to see if there are any queries running for more time and blocking the other queries from running. And if there are any ad hoc requests, we work on that.
Okay. Can you please tell me what are, I mean, what are ad hoc requests? Can you please tell me what type of requests you get?
Yeah, we get some requests from application team, like their queries are running for more time. So in those scenarios, we just check how we first get the list of tables that is used in that query, and then we go and check all the table design, whether they have designed the tables in correct way. We check the distribution key, sort keys, and then we also run explain to see the query plan. If we see any table is being redistributed during the execution time, we suggest them to go for a distribution style with key or distribution style as all, depending on the table size. If it's a small table, we suggest them to use a distribution style as all. If it is a big table, then we ask them, depending on the join columns used or the aggregate function used in the query, we ask them to use that particular column as the key for the distribution style. Sometimes they ask us to unload the data and give it to them in a Excel or a notepad file. We use the unload command and download that to an S3, and we give them the S3 location. the application team or the uh, other vendors, they download from the S3. These are some of the ad hoc requests we get.
Okay. Okay. Cool. Can you please tell me, like one or two issues that you faced during your, I mean, development?
Okay. So as I described earlier, we had a query that was running for a long time. So when application team came to us, we did an explain on that query and we analyzed, we evaluated the query plan. We noticed that it was the table was being redistributed during the execution time. So we suggested them to use distribution style as all, as the table was a small table having 10,000 rows. So they modified it and that brought down the execution time drastically.
Okay.
And during the when they gave us a file and they asked us to load that file to the Redshift table. So we used to copy command to load from S3 location to our table. At the time, there were some errors in few records. The delimiters are not set correctly. So we had a error during the load. So we checked that STL load error table, STV load error table, and we identified the records that is having incorrect delimiters. We requested the application team to correct and resend it. After they corrected and resend it, we load them into our Redshift tables and give it to them.
Okay. Fine. Okay. So now let me come back to the, I mean, general concepts. Can you please tell me what are slowly changing dimensions?
Okay, there are three categories: slowly changing dimension 1, 2, and 3. Slowly changing dimension 1 means it stores only the current data. Slowly changing dimension 2 means it stores the current data and all the historical data. SCD3 is current data and recent old data, maybe 2 or 3 years data. Those are the three categories of slowly changing dimension.
Can you please tell about them?
Yes. Let me give an example. For example, the sales table, the monthly sales table will have only the current month's sales data. That is a SCD1, and SCD2 is as I am working in automotive domain, we store the warranty of every vehicles that are being sold. We will be having all the historical data, even if the vehicle is sold before 15 years, still we maintain it because due to warranty or due to some faulty part, we can get a request. So those type of warranty data we store it in SCD2. SCD3 is current data plus the most recent data. Maybe year or two sales data we store it in SCD3.
Okay.
It
Okay.
depends
Okay.
on the data that we are storing. We can create SCD1, 2, or 3.
Okay. Can you tell me how do you implement SCD type 2?
So it's an another table. It depends on the data we store. Normally, how we create a table, we have to create table name and the columns, and depending on the data we are storing there, it is an SCD1, 2, or 3.
Yeah, yeah, I got it. I was asking, um, do you have idea how to implement SCD type 2?
How do we implement? No, Krishna.
Okay, fine. Yeah, that's fine. So can you tell me what is the difference between star schema and snowflake schema?
Yeah. Star schema is a fact table surrounded by denormalized dimension tables. So in star schema, the queries will be faster because there is no, you have the dimension tables are denormalized, so there won't be any much joins in the queries. So the queries will run quicker, but it will occupy more space. In Snowflake schema, it's a fact table surrounded by normalized dimension tables. So it occupies less space because the tables are normalized, but query execution time will take more compared to star schema because we will be having joins due to normalization.
Okay. Okay. So what do you suggest? The star schema or snowflake schema?
So generally, maybe it depends on our requirement, but generally we prefer Snowflake schema. In some cases, if we prefer query execution is more important than reducing the space occupied. In that particular scenario, we can go for a star schema, but generally they go for a Snowflake schema
Why?
because the tables are normalized one, so there won't be data integrity issues.
Okay.
As the tables are denormalized in star schema, same data can be available in same column can be available in multiple tables. There is a possibility of data integrity. One table may be having a different value for the same record. The another table will may be having a different one. So it is preferred to go for a Snowflake schema.
Mhm. Can you tell me again what is the problem with star schema?
So the tables are not normalized. So it's the
Okay.
same column may be residing in multiple tables, and it is possible it can have a different values due to some error in the ETL process that is loading the data. So we can get a data integrity problem. So Snowflake schema is better than star schema, but in scenarios where we are more concerned about query execution speed, only in that case we can go for a star schema.
Okay. Okay. Fine. Yeah. Can you tell me the architecture of Redshift?
Yes. So Redshift has a leader node and then the compute nodes. So leader node, it takes care of communication between the BI application, other applications, and also it prepares the query plan for execution. It manages the communication between the compute node and leader node. And under a leader node, we will be having multiple compute nodes depending on the node types that we selected during the cluster creation. So each compute node will be again divided into a slices. Slices are like a virtual nodes. So it is in compute node, all the data will be stored and all the query execution happens in the compute node. After that, leader node aggregates the result set it gets from all the compute nodes, and then it sends the result set back to the application that requested the query. So it's a leader node, compute node. It's like a two-tier.
Okay. Then, hello.
Yeah, yes, Krishna.
Yeah. So what after? Like, how does it help?
So we are due to this architecture, we are having a parallel execution. A query is being executed across compute nodes, so it will be quicker. It's Redshift supports parallel processing, massive parallel processing. So the query execution will be quicker compared to other data warehouses where this parallel processing is not available.
Okay.
That is one of the advantage of Redshift, massive parallel processing. So this
Okay.
compute nodes execute the query on the data that is residing in that compute node alone. Like that, parallelly the execution happens, and then the leader node consolidates that and give it back to the application, BA application.
Okay. What are Redshift maintenance activities?
So maintenance activities are analyze and vacuum. So analyze means before analyzing, let me come to vacuum. Vacuum is generally in Redshift when we are issuing a update query or a delete query, the records are not actually updated or deleted. They are only marked for deletion. And then a new record will, when we are issuing an update query, the old record will be marked for deletion and a new record will be inserted with the updated value. So, so physically the records are not yet deleted from the Redshift tables. So only when we issue a vacuum command, Redshift goes and deletes the records that were marked for deletion. So after that, when we issue an analyze command, it rearranges the record depending on the updates that we inserted everything. So it rearranges and it updates the statistics so that next time when the query is any query is being executed, it uses the latest statistics and the query execution will be faster. So whenever we issue an analyze command, we have a column called stats of in SVB table info. If it is showing us 0, then the statistics are up to date. If it is showing us 100, then statistics are not up to date. We have to issue an analyze command.
Okay.
So generally,
Okay. So,
when there is a performance issue, we also check whether stats of is showing us 0 or not. If it is not, then we issue an analyze command.
okay. Okay. So, what happen if you don't regularly, update statistics, or if you don't do the vacuum? What happens?
Okay. If you are not issuing a vacuum regularly, then what happens is the space will be occupied, the disk space will be occupied by the records that are marked for delete. So the query performance will get degraded. So the query that is taking, which was running quicker, will start taking more time when the number of rows marked for delete is keep on increasing. So to have the performance of the cluster optimum, we have to issue vacuum command and analyze command regularly. If you are not issuing an analyze command, then statistics won't be latest one. The queries will be still using the very older statistics. That also will cause the query to run for long time.
Okay. Tell me, when the statistics will be collected, or will it be collected? And similarly, tell me when the vacuum should be run, or will it be done automatically? Okay, if not done, first of all, when should we run it? If at all we have to run, I want to know about analyze and vacuum. Okay, I want to know whether statistics need to be run. If run, what are the ideal way or ideal time we should run? Similarly, tell me, is there need to run vacuum? If there is a need, then when we should run?
Okay, so vacuum, generally we have to execute the vacuum during when the cluster is in idle state, because during vacuum other applications, the BI or ETL, they may not be able to access the tables on which the vacuum is being run. So we have to use the vacuum during an when the cluster is idle, and analyze also we have to do it. Generally, when the cluster is in idle state, we have to issue vacuum and idle. But nowadays, vacuum is happening automatically in Redshift.
Okay.
So one of the latest feature they have added. So vacuum happens automatically whenever there is a huge updates or huge deletes happens. Redshift recognize that, and it is issuing a vacuum automatically.
Okay. Okay. For example, I have, for example, I have inserted 100 million records into a table.
Okay.
Okay. I have inserted 100 million records into a table. Okay. And then,
Okay.
okay, after inserting the data, okay, there are some updates on the table. Okay. Let's say as part of that updated, some 50 million records got updated. Okay.
Okay.
So I have just loaded this table into production.
Okay.
Okay. So as part of history load. So tell me, is there any need for analyze or no? And if yes, then why? And also tell me, is there any need for vacuum? Yes or no? If there is any need for yes, then why?
So you have from S3 you have loaded 100 million records into Redshift table, correct?
Right.
Okay. So it is a fresh load.
Yeah.
So okay, if it is a fresh load, then no need for doing a vacuum. But we have to do an analyze. So when we are issuing an analyze, then Redshift collects the statistics of the table. In each 1 MB block, what is the lowest and highest data that is being stored? Like that, it collects the statistics and it stores in the metadata. Only then, when we are next time when we are issuing a query against the table, it knows which blocks has to be go and looked into to get the data required. It can just directly skips the blocks that are not required, because Redshift knows lowest and highest value that is stored in each block. For example, if the lowest is 1 and highest is 50, just a employee number. But if in the SQL query, if you are having a var class where employee number greater than 75, then Redshift knows the first block doesn't have, it has only from 1 to 50, so it directly skips the block 1 and it goes to the block 2. So these types of statistics will be collected when we run the analyze command. So we have to run an analyze command, but vacuum is not required as it is a fresh load. First time we are loading from S3 to the table.
But after the load, I have, ran the update statement, right, which updated 50 million records. So do you need vacuum or no? If
Yeah, in
yes,
that case, if we have a update statement, then definitely we need a vacuum, because when we are updating 50 million records, the old 50 million records will be marked for deletion and the new 50 million records will be inserted. So the table will be having 150 million records now physically. So only when we issue a vacuum, the records marked for deletion will be removed physically. Otherwise, the 50 million records will be occupying disk space in the cluster.
okay. Okay, fine. Can you tell me what are the different types of instance types in Redshift?
Instance type.
Yeah. What are different instance types available in Redshift?
So, are you asking about the DC2, DS2, and RA3 instance type?
Yeah, yeah, no types. Instance types means,
No,
yeah, no types.
no types. Okay. So we have three types: DC2, DS2, and RA3. Uh, DS2 is dense storage. So in our cluster, if you are more concerned about the having a more, we are giving primary importance to the storage. In that case, we have to have the node types as DS2. But in our cluster, if you are more concerned about the computing power, the query execution should be fast like that. In that case, we have to go for DC2. And RA3 is the recent one. They have in RA3, we are just paying for only the storage space we are occupying it. The computing is not calculated, only for the storage that we are using it. And DS2, AWS is planning to sunset DS2, and they are asking us to migrate to RA3 now. There are these are the three different node types.
Okay. Like, what do you suggest to the customer whether they should use DC2 clusters or RA3 clusters, or why there are different node types, and what do you suggest to your customer?
So after RA3 was introduced, RA3 is the one we are suggesting to the customer, because it will bring down the cost for the customer if they are using an RA3 node type. Because even though if you are having some 5 instances of RA3, the total is 200 GB, but if you are storing data only for 50 GB initially, so we will be charged only for that 50 GB. But it is not the case with DC2 and DS2. So as cost wise, RA3 is beneficial for the customer. So we suggest RA3.
Okay, what is the cost for RA3? What is the least price for RA3? In RA3, which node is least price?
Actually, I don't remember the exact cost, but we have that AWS calculator page. Generally, we go and look up there.
Okay, okay, fine, fine. Okay. So you say that you will recommend RA3. Okay, if you
Yeah,
recommend
yes,
RA3, tell me why. Then tell me why.
yeah. RA3 will be cheaper compared to DC2.
See, DC2, there are two things: DC2 large and DC2 8x large.
Yes.
DC2, I mean, DC2 large will come up with $0.25 per hour, whereas
Okay.
RA3, the small node RA3 XL Plus itself will comes with $1.086. So which is cheaper, $0.25 or $1.086? Which is cheaper? The starting price in RA3 is $1.086, whereas in
Okay.
DC2 the starting price $0.25 per hour. What do you think that which is cheaper?
So actually we have to compare the storage capacity and the throughput rate, IO throughput rate also. We have to compare together with the cost. We should not take only the cost alone. For the similar storage space and throughput, if we compare the DC2 and RA3 will be cheaper.
Okay. Okay, fine. Yeah. So, tell me, like, how the copy job will work.
Copy command.
Yeah. Yes.
So copy command is used to copy a file from S3 to Redshift tables. So before issuing that copy command, we should have the S3 file ready to be loaded, and the table should be already created in Redshift, and we should have a IAM role created and correct policies attached. We have to create a IAM role, and that role should be associated to the Redshift, and we have to attach permissions to that IAM role. As we are copying from S3 to Redshift, we should attach S3 read access to that role, and then
Okay.
we have
I'm asking
we
how
have
the copy. Okay. Okay. Just I'm asking how the copy script will work. Okay. We have a role. We have policies attached. Okay. So yeah, that's all fine. But I want to know how the copy command will run, or what is the internal background process that happens, or how the copy job works.
it copies the records from that S3 file and then loads to the Redshift table.
Okay.
Internally, so it can load multiple types of files: text file, comma delimited file, parquet file.
Okay.
It directly loads Krishna from S3 to Redshift tables.
Okay.
So
Okay.
this copy and unload are the Redshift utilities for loading and unloading data. Like every database have their own utilities. Like that, Redshift has copy for moving from S3 to Redshift table, and unload is from unloading data from Redshift table to the S3 file.
Okay. Yeah. Can you tell me what is the spectrum?
Yes. So Redshift spectrum, it is a way we can access the S3 files directly from Redshift without loading that into the our Redshift table. Directly we can access the S3 files. We can write a join query between a Redshift table and an S3 file. So how we can achieve that is first we have to create an external schema, and then we have to create an external table on that schema. When creating that one, we have to give that file location in S3. After that, we can directly write a join query between the Redshift table and the external table that we created for the S3 file. So the main advantage of Redshift Spectrum is we are saving the space in Redshift because we don't have to load all the data into Redshift table. It is costlier. So instead, we can keep it in S3 itself, and then we can write join queries to pull the data from that. Here also we
Okay.
have to create the IAM role and associate that role to the Redshift, and then attach permissions S3 full access and AWS Glue full access we have to give. So
Okay.
generally
What
very
is
old data which is rarely used, we can keep it in S3, and the regularly used data we can have it in Redshift.
okay? What is blue? You said blue and all.
So Glue is another ETL. I think it is a ETL one. I haven't worked on Glue, but I remember it is another ETL process that can load the data from different sources, different databases. It can extract, transform, and load it into AWS Redshift. But I haven't worked on AWS Glue.
Okay, fine. So a customer comes and asks you that a query which used to run every day 2 minutes. Okay, it's
Okay.
running from last 4 hours, but it's still not completed.
Okay.
Okay, so query which used to run every day 2 minutes, it's still running from last 4 hours, but still not completed. And yeah, he comes and asks you for your assistance. So how do you help that customer?
Okay. So the first step is we go and check that STB in-flight table to see what are all the queries that are currently running. So and also we see, is there any other query that is blocking all other queries? Let's say there is another query which is running for more than 10 hours. Due to that, the customer reported query is taking more time. Then we check with who has run that query, and then we cancel that query. That is one thing. Next one is we will see if there is any block on the table that is used by the customer complaint query. If there are any blocks, we go and see why there is a block for that particular table, and then we run a explain on that query and see whether any redistribution is happening in that one. And then we see the tables used in that query, whether statistics is up to date. If the stats of is showing as 100, we know that due to the statistics is off, it is taking more time. So these are the ones that we check at the query level. And then if everything is fine, there is no other query that is blocking this query, the tables are available, tables are not locked by some other process, statistics is good, explain is also showing everything is good, there is no redistribution happening. In that case, then we may think it may be a system issue. So these are the steps generally we follow to debug why the query is taking more time.
What type of system issue?
System issue, whether the cluster has reached its capacity. If we have to add more nodes, space issue, disk space issue, if we have those things, we check.
But if that is the issue, all the queries should run long, right?
Yes.
Then this is not the issue with all the queries. Only his query is running long.
In that case, anything may be off, which I said earlier, whereas either statistics may not be up to date. The query may be using a product join. There may be some logs on the table that are used by this query. Some other process may be having a exclusive log on those tables. Like that, any one of them will be applicable. We have to resolve that one so that this query can run quicker. Generally, what
How do
happens
you
is
know?
some other query. Yeah.
Yeah, yeah. Go ahead.
Generally, some other query may be running for long time. That will cause other queries in that queue to get delayed. We identify that query, we notify the user, and then cancel that particular query so that other queries can run quicker.
Okay. Okay. How good are you in SQL?
Yeah, I am good, Krishna. Because earlier I was working in application team. At that time, we used to write SQL queries. Before I moved to Redshift, I was working in application development. At that time, we write SQL queries in our application code to access the data.
Are you able to
I
share
am
your
good in this.
screen?
Yes, Krishna. Share my screen.
Yeah. Are you able
Okay.
to? I mean, I'm asking. Would you able to share your screen?
Yeah, sure, Krishna, I can do.
Because I will ask you to write something. Would you able to write now or no?
Yeah, yeah, yeah. 1 second.
Yeah, sure.
So is the screen visible?
Share the screen. Click on share screen.
Yeah, I have done. VK is screen sharing. A message has come. So is my video visible, Krishna?
Video not visible now. I mean, no problem. If you can share the screen, that's fine.
Yeah, I have started screen sharing. VK is screen sharing now.
Okay. You log in through
But
laptop
nothing
or
is
phone?
mobile. Because actually
In mobile,
my laptop got restarted. It is doing some updates. I am trying to power on.
okay, fine. But anyway, if mobile, then how do you write? I have sent you one table. Okay. Anyway, no
Okay.
problem. I will tell you. I have a table called employee. Okay.
Okay.
Employee, and it has columns like EMP ID, EMP name, department number, and salary. Okay.
Okay.
So can you please write a query? Okay. So I'm typing you the message. Can you write a query to get department wise average salary?
Department wise average salary.
Yeah, that is query one.
Okay.
It would be better if you can share the screen, or I mean, anyway, I'm not able to see your screen. You can tell directly.
Okay. Yeah, I'm just 1 minute, Krishna.
Yeah, take your
Department.
time.
Okay. Select department number, comma, average of salary from employee, group by department number.
Okay. Can you send me that query?
Yeah, yes.
Okay, fine. So I have sent you one more query. Can you read it out?
Yeah, can you write a query to get all the employee details whose salary is more than their department's average salary?
Yeah. Do you understand what I mean?
Yeah, yes, Krishna.
Yeah. So write a query to get all the employee details. Okay. I want all the full details of an employee. Okay. Okay.
Okay.
But what type of employees, their salary should be more than the department's average salary.
Okay, Krishna.
Got it?
Yeah, yes, Krishna.
Yeah. You can take time and let me know.
Yeah, Krishna. Hello.
Yeah. Yeah. Are you done with?
No, Krishna. I'm just trying.
Yeah. No problem. Tell me.
Yeah.
I mean, if you want to take time, take. Or if you're done with it, you can send the query.
So I'm not sure how to write this. Query is more than their department salary, sir.
More than the department's average salary. Are you clear with the question?
Yeah. Yes, Krishna.
Yeah. Okay. So you can send me like whatever you wrote.
No, actually, I haven't completed. I'm stuck here. Where salary greater than? I'm trying to see whether we have to write a join query or a sub query here.
If time is given, can you write now? Maybe you can take 2 more minutes. If you say you can write, I can wait. Otherwise, we'll proceed.
Yeah, we will proceed, Krishna.
Okay, fine. So, okay. I want to know the departments, okay, in which more
Okay.
than 10 employees are working. Okay, write a query.
Department. Okay.
Okay, write a query. Okay, to get the departments in which more than 10 employees are working.
Yeah, Krishna, I have sent a query.
Okay, 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 fine. So, can you read out the query?
Yeah, select
I mean,
department number.
yeah,
Select department number, comma, count of star from employee group by department number having count of star greater than 10.
okay. Can you tell me what is the output it displays? output of this query.
So departments that has more than 10 employees.
Yeah, tell me how the output will come. I want to know how the output will look like.
Yeah, for example, department number 0, 1, 15, like that. 2, department number 2, count 20. It will be 2 columns. First column will be the department number. Second column will be the number of employees in each department, like 15, 20, 23.
Okay, okay, cool. Yeah, I think I'm done with my interview. Do you have any questions?
So how did I perform? Where should I improve?
No, you see, you don't ask the interviewer these questions, right?
Okay, okay, okay. Okay, Krishna.
Okay, cool.
That's all, Krishna.
Yeah,
Thank you for the giving me an opportunity.
yeah. So, okay. Nice talking to you.
Yeah. Thank you.